welcome all to the NPTEL's live interactive session on engineering metrology. So, I am additional TA Shubham Jaiswal. I am a research scholar in the Department of Material Science and Engineering at IIT Kanpur. So, in this live session, we will be discussing the problems and some numericals questions that are similar to your assignment. So, we will try to practice as much as possible. And if you have any doubts while solving the questions, so you can put that in chat box. So I will answer that one possibly. And are you able to hear me, everyone? Okay. So let's begin our session. Today's session that is live interaction session on engineering metrology. So here are some questions can we eliminate the instrumental error from our observed value? So are you able to answer this? Anyone? Rajnish Pandey? Okay. So we will take one example. Suppose how we have one ammeter and it's continuously showing a reading of 1 ampere. Okay, when there is no input, but still it is showing 1 ampere reading. So, and when we actually turn it on and measure the reading, it will be showing the 4 ampere, suppose. Okay. So that 1 ampere was previously there, and if we minus that one, so that actual reading will be the 3 ampere. So from this example, what we can say that we can eliminate the instrumental error from our observed value if we know the error percentage or error value of the instrument. So the answer for this question will be yes. So the second question is different types of scales have different least count. So whether this is a true or false. So can anyone tell me? Okay. So let's consider 3 types of scale. Like one is the vernier. Okay. So let's consider one vernier scale. Okay. This is the movable jaw. This is the fixed jaw. And consider the screw gauge. Okay. I am not good at drawing, so please bear with me. So, and if we consider our normal scale, so as we can see that the vernier scale, the least count of vernier is 0.01 mm. Okay, that is the means. This is the minimum distance that we can measure using the vernier scale. If we consider the screw gauge, the minimum the least count is 0.001 mm. And if we consider the steel rule that we use day to day, so its least count is 1 mm. So from these all 3 examples, what we observe is that the different types of scales has the different least count. So this sentence is true. Okay, so like the different types of scales will be having the different least count, and some different scales can have also same least count also. Okay, so we can't say like different types of scales always have the different least count. So okay, if we go to the next question. So, if the third question is that, what is the least count of popular rule that we use in our daily life to measure the distance up to 15 centimeter? First option is 1 mm, second is 7.5, third one is 0.5 mm, and fourth one is 15 centimeter. So let me first draw the 15 centimeter scale schematic. So as we all know, there are very small divisions, and after each 5 division there will be a one big line will be there that will be showing the 5 mm. Okay, so from this schematic, you can say that the minimum distance that we can measure is 1 centimeter. Actually, I will show you the real scale. Okay, so here I have a steel rule. I don't know whether you are able to see it or not. Okay, let me. Turn on the video first. So here you can see I have a scale, and here some markings are there: 1 centimeter, 2 centimeter, 3 centimeter. So from here you can see the minimum the distance that we can measure using this scale is 1 mm. Okay, here's one marking represents the 1 mm distance. So the correct answer to this question is will be 1 mm. Okay, so minimum distance that we can measure accurately is 1 mm, but we didn't consider the points like the line thickness. Okay, so sometimes what happens that line will be having some thickness, and it will give some error, but that error will be very less. So we generally don't consider in our day-to-day rough calculation. But when we need a more accuracy, then that everything matters. So that's why we are producing the very high-end equipments for the measurement. Okay. So the next question is values or readings taken from instrument always remain same when we see the instrument from different angles. Okay. The simple example we can solve this question by using simple example. Let's consider our watch. Okay. Suppose the minute hand is at 12. Okay. Okay. So if we see perpendicular to that hand, okay. So what we will observe, the hand will be at 12. Okay, but when we observe from this side, so we will see that this hand is lying somewhat here. Okay, like say you can say 11:59. Okay, and if we see from this side, then it can show that it is 12.1 like that. Okay, so what we are seeing is the means it is misguiding us. Like direction will misguide us if it is not perpendicular to the indicator. So the question to this answer will be like values or readings taken from instrument always remain same when we see the instrument from different angles is false. As we change the angle, the reading is changing. So we can say that it will not give the means the instrument will not give the same answer from different angle. So this is all for today. And if you have any questions, you can ask me, Manoj. Okay. So we will wind up this session here itself, and we will meet on next Tuesday at this same time only. And thank you for attending, and all the best.